Hi everyone. So today we will discuss the January 2022 Pure Mathematics paper 3. Question number 1. They say find using calculus the x-coordinate of the stationary point on the curve with equation y equal to 2x plus 5 times e to the power 3x. Okay. So how do we, stationary point in the sense what? A stationary point is a turning point. At that point, your dy by dx becomes equal to 0. So shall we find what? We need to find the value of dy by dx here. Let's calculate the dy by dx. So what do we do here to calculate dy by dx? There are two options here. You could either expand the bracket or you could do it in this manner by using what rule? Product rule. In product rule, the first one differentiates while the other waits. Then, each person has to differentiate in their own turn. So what do we get here? dy by dx. So first I'll keep the 2x plus 5 waiting. What happens when you differentiate e to the power 3x? E to the power 3x differentiation is e to the power 3x into 3. Okay. Plus, then the next one, e to the power 3x waits while you differentiate 2x plus 5. What happens when you differentiate 2x plus 5? Just simply 2. Is this clear? Okay, so we are not done with it. Now we need to make our dy by dx to 0 and get the turning point. So at stationary point, dy by dx is 0. At stationary point, we set the dy by dx to 0. So 0 equal, let me fix this here, 3 times e to the power 3x times 2x plus 5 plus 2 times e to the power 3x. So we can simplify here. Shall we take e to the power 3x out? E to the power 3x, when I take it out, I get here 3 times 2x plus 5 plus 2. So I think you do know about the e to the power 3x graph. When you know about the e to the power kx, so basically ex graph is something that looks like this. Can it ever reach 0? E3x can never be 0, right? So that means who is going to be equal to 0 here? So your 3 times 2x plus 5 plus 2 becomes equal to 0. Solve this and make x the subject. So you get here 6x, 3 times 5 is 15, plus 2 equals 0. You get here 6x equals minus 17. So x equals to minus 17 over 6. Okay, is this clear? Okay, moving on to question number 2. Show that the equation 8 cos theta equals 3 cosec theta can be written in the form sine 2 theta equals k. So when you see sine 2 theta, what comes into your head? Definitely we understand we are going to use the double angle rule. So what's the double angle rule that we use here? Sine 2 theta is equal to what? 2 sine theta cos theta. This is the main double angle rule we have for sine. Okay, so then we need to, part A, they have given us the equation 8 cos theta equals to 3 cosec theta. So what do we do here? First, what we can do is we can rewrite cosec theta. So who is cosec theta? Cosec is 1 over sine. So take the sine to the other side, 8 cos theta into sine theta equals 3. So then to make, now you can see here, to make sine 2 theta, all I need is a 2 sine theta cos theta. So what do we do here? We can break the 8 off as what? 4 times 2. And then you can write the cos theta sine theta equals to 3. So basically 2 cos theta sine theta equals to 3 over 4, which means 2 sine theta cos theta or 2 cos sine, basically both are the same. It's actually sine 2 theta and sine 2 theta equals to 3 over 4. So just 3 marks for this question. Then they say in part B, hence find the smallest positive solution of the equation 8 cos theta equals 3 cos theta, giving you answer in degree to 1 dp. Okay, they just want the smallest positive. Now, we actually reduce this equation onto this, right? 8 cos theta equals 3 cos theta, we reduce it to sine 2 theta equals 3 over 4. All you need to do is to solve it and get the very first positive answer, isn't it? So what do we do here? We say, first of all, we don't, we can work with the compound angle. You can say let x be equal to 2 theta, and we don't have any range to fix here. So then this becomes sine x equals to 3 over 4. They want the answer 1 dp and in degree. So your calculator must be in degree mode. So get the sine inverse and get the answer. And what quadrants do we need to choose? Sine inverse 3 over 4. This is a positive. So choose quadrants where sine is positive. All silver teacups. Anyway, we only want one answer, right? So we don't need to go for the quadrants also. So all silver teacups, I just want the very first answer that is positive. So how much is sine inverse 3 over 4? Give me a little bit extra decimals. 48.5. Don't take it to 1 dp. Final answer should be given to 1 dp. The x answer is not final. Remember, the theta is the final answer. So what is this? 48.590. Okay, so 48.590. Type this in the cal. Sine inverse 3 over 4. So that means I want only the very first answer. This is the smallest positive answer I get for x. 48.590. Who is x now? X is 2 theta. X is 2 theta, which means what's our theta value? 48.590 we divide by 2. What do we get then? 24.3 when you round it off to 1 dp. Okay, is that clear? Question number 3, part 1. Find in simplest form the integration of 2x minus 5 to the power 7. Okay, so how do we integrate? I have my general rules of integration here. So these are the rules that we have that they give us. I mean, I've written this in the general form. So which rule do we use here to integrate 2x minus 5 to the power 7? Obviously, rule number 1. Okay, so it's quite simple. So what do we get here? Part 1, integration of 2x minus 5 to the power 7 gives me. So you can see here ax plus b to the power n is 1 over a. Basically, we divide by the coefficient of x, right? Which is 1 over 2, and then 2x minus 5 to the power 7 plus 1. We add 1 to the power. Divide by power 8, divide by 8. And then don't forget the plus c. So now they say to give you answer in simplest form. So is this in simplest form? No, because you have 1 over 2 and there's a 1 over 8 here. So that needs to be simplified, and that's the simplest form. Okay, so then you get here what? 1 over 16 times 2x minus 5 to the power 8. So okay, you don't go to attempt to open this bracket at all. This is the simplest form, just 2 marks. Okay. Roman number 2, show by algebraic integration that integration from 0 to pi over 3 of 4 sine x over 1 plus 2 cos x with respect to x is ln a, where a is a rational constant to be found. So what's a rational constant? A rational constant means a fractional constant. So it's a fraction value here. So ln something like 1 over 2 or ln 5 over 6, something like that. So anyway, here your a is a rational number, fraction value. Okay. So now the biggest problem here is how do we integrate this? What rule do we use to integrate? So what rule do we use? Now you can see you have a fraction here. So but rule number 3, these kinds of stuff don't work. We need to definitely go with something like what? Either with 10 or with 11. So f dash x over fx with respect to x, or f dash x fx to the power n. So in here I think we can see we can definitely go with f dash x over fx. Right? Where you have the differentiation of the denominator on the numerator. But you must have it perfectly. You must have it the differentiation of the denominator on the numerator perfectly. So do we have it? Shall we check on that? So integration from 0 to pi over 3 of 4 sine x over 1 plus 2 cos x with respect to x. Okay. So my fx value here, my denominator is 1 plus 2 cos x. Can you all tell me what's the f dash x here? What should be the f dash x? The differentiation of cos x is, so now it's differentiation, okay? The not integration, it's a differentiation. So do you remember the differentiation rule? Differentiation of cos is negative sign, right? So then one differentiation is 0, 2 times the differentiation of cos is negative sign. So minus 2 sin x. So you can see here on top, my numerator is, I have a 4 sin x. Basically, I have the most critical person, because we can't input any x value. We can only input constants into the sum. So the sin x is there, only minus mark is not there, but I need to make this a 2. So I already have 4 here. What we could do is, yeah, you could break the 4 as 2 times 2 if you want, or else you can completely take the 4 out like this. Okay, and then you have here just sin x over 1 plus 2 cos x. And then what you could do is, now you know your f dash x needs to be minus 2 sin x, right? So then you multiply this with a minus 2, and to cancel out that effect, divide with a minus 2 outside. So inside the integration, I put a minus 2, and outside I put a minus half. Okay, so in that case, I don't do any change to my sum. Okay, so then Now I have the perfect f dash x over fx. So now I can go with rule number 10. What's the differentiation of f dash x over fx? It's equal to ln fx, which means ln log value of your denominator. Okay. So then minus 4 divided by minus 2 is minus 2, integration sign. No, we are integrating. So then I get here ln 1 plus 2 cos x. Okay, and then your limits are from 0 to pi over 3. Input your limits minus 2 times ln 1 plus 2 cos pi over 3 is the first value, minus ln 1 plus 2 cos 0. Okay, so make sure your cal is in radian mode. Type the values ln. What's cos pi over 3? 2 cos pi over 3 is cos pi over 3. Yeah, we get here half. Half into 2 is 1. 1 plus 1, I get here ln 2. Minus ln. What do we get here? Cos 0 is 1, right? Cos 0 is 1. So I get here 1 times 2 is 2. So 2 plus 1, I get here ln 3. Okay, so make sure you give these, type this separately in the cal. I mean, you shouldn't give it with the ln, or else you might get decimals. We need to get our answer in exact form. So I get here minus 2. Shall I open the bracket? I mean, minus 2 ln 2 plus 2 ln 3. Then we multiply with minus 2. And then your answer needs to be a single logarithm. Okay, so how do we make it a single logarithm? You can, I could have like only put the negative sign in. Okay, or else, okay, so there are many ways of proceeding from here. So either you could take the divide, a subtraction of two logarithms is a division under a single logarithm, right? So I anyway prefer to keep a positive 2 out here and get ln minus ln 2 plus ln 3. Okay, we can do this in many ways. So then I get here 2 times. What do I get here? A subtraction of two logarithms is a division. So under a single logarithm, the positive logarithm comes on top, the negative one comes down. And then is this the answer format that they have given? No, their answer, they don't have any number in front of the ln. So then we should not have any value in front of the logarithm, which means we need to take the 2 inside. It when it goes inside to the logarithm, it becomes a power. So ln 3 over 2 to the power 2, which means ln 9 over 4. Okay, so this is the answer. So you could simplify this over here. You could immediately, you could have taken ln 2 over 3 and taken it to the power minus 2. Even that would have been fine. Like from here, I could have taken minus 2 times ln. Another alternative is I could have taken minus 2 times ln 2 over 3 at this point. And then the power minus 2, I could have taken inside as the power minus 2. So 2 over 3 to the power minus 2 gives you 9 over 4. You give in the cal, you type in the cal 2 over 3 to the power minus 2. Just type it and you get 9 over 4. Okay, so any method, just show one method. Question number 4. The growth of a weed on the surface of a pond is being studied. The surface area of the pond covered by the weed, a square meter, is modeled by the equation a equal 80 p e to the power 0.15 t divided by p e to the power 0.15 t plus 4, where p is a positive constant. So keep these things in mind. P is a positive constant and t is the number of days after the start of the study. Given that 30 square meter of the pond, of the surface of the pond was covered by the weed at the start of the study. What do you mean at start? Start means time is 0. So at time 0, the area is 30 square meters. So these are the things you need to note down. And then 50 square meter of the surface of the pond was covered by the weed t days after the start of the study. Okay, so t days later, when time equal to capital T, the area is 50. They are asking you show that p equals to 2.4. Okay, how do we show that p equals 2.4? The first thing is in part A. Let's input the values that we know. So the first one I'll use is when time is 0, area is 30. So we'll use that area is 30 square meters. So A equal 80 p e to the power 0.15 t divided by p e to the power 0.15 t plus 4. Let's input A is 30, time is 0. 80 times p e to the power 0.15 t into 0 means basically the whole thing, the power is a 0. Divide by p e to the power 0.15 into 0 means it's the power 0 plus 4. Okay, is this clear? So any number to the power of 0 is Any number to the power of 0 is a 1. So e to the power 0 is a 1, e to the power 0 is a 1. So I get here 80p divided by p plus 4. And now it's just what? It's just a matter of making p the subject. So 30 times p plus 4 equals to 80p. So I get here 30p plus 30 into 4 is how much? 120 equals to 80p. So I get 120 equals 80p minus 30p, which gives me how much? 50p equals 120. Is that correct? So 120 divided by 5 gives me the p value of 120 divided by 50, which is the 2.4, right? 120 divided by 50 is the 2.4. Part B, find the value of t giving your answer to 1 dp. So capital T is actually what? So capital T is the time when the area is 50 square meters, isn't it? So what we do here, take your equation, replace the area with 50 and replace the, and actually we found the p value as exactly as 2.4, right? Input that and you're supposed to make t the subject. Let's do that quickly. And they have told you all here, solutions relying entirely on graphical or numerical methods are not acceptable. Okay, so that means you cannot give this in the calculator and ask the calculator to solve it for you. So you must show relevant working and make t the subject. And I mean, you have to show relevant working here. So 50, I replaced a with 50 equals 80 into p is 2.4 into e to the power 0.15 capital T, right? I replace the simple T with capital T divided by P is again 2.4 into e to the power 0.15 T plus 4. Okay, are you with me? So now what we do here is we need to make our T the subject. So how do I make T the subject? Take this entire term to the other side and multiply it with the 50. So what do we get here? 50 multiplied by 2.4. Can I know the answer for 50 multiplied by how much? 120 e to the power 0.15 t, and then plus the 50 multiplies with the 4. The 50 will multiply with the 4. What do you get? 200 equals, can I know 80 times 2.4? 192 e to the power 0.15 t. So now how do we make t the subject? Take all the terms with t to one side. Basically e to the power 0.15. Take it to one side. So you take this to this side over here, and I get here 200 equals 192 e to the power 0.15 t minus 120 e to the power 0.15 t. So these are like terms. Do you agree they are like terms? So you can subtract them. 192 minus 120 is 72 e to the power 0.15 t. So now take the 72 to the other side as a division. So 200 over 72 equals e to the power 0.15 t. Now, what's the next step? I need to, now t is a power here. How do we get rid of the, how do we make t in the power? How do I bring it down? We use ln, right? We use both sides logarithm. We basically use natural logarithms, base e logarithm. Okay, so we use, there's a reason why we use base e logarithm, because we have e here. Okay, because you know the rule is ln e becomes what? 1, because ln is log base e with the base e. So when you have a logarithm of e to the base e, it becomes 1. Okay, so then we'll write here ln 200 over 72 equals, what happens here? The power inside the logarithm, when you have a power, the power comes front. So I get here 0.15 t comes forward, and you get here ln e. Do you see the 0.15 t comes in front? So ln e becomes 1. So now can't you make t the subject quite easily? So t equals 1 over 0.15 ln 20 over 7. Have they asked for an exact answer? Oh, they find the value of t giving you answer 1 dp. Okay. So we can now type the whole thing in the cal and get the answer correct to 1 dp. 200 over 72. Yes. This is 200 over 72, which can be simplified. 1 over 0.15, how much is the simplest value for 1 over 0.15? So this is 1 over 0.15 is 20 over 3. ln 200 over 72, what would be the simplest? 25 over 9. So in an event, if they wanted the exact answer in the simplest form, this is what we could give. But they want the answer to 1 dp. So 6.8 days correct to 1 decimal place. Okay. Okay, moving on to the next part. The wheat grows until it covers the surface of the pond. Find, according to the model, the maximum possible surface area of the pond. Okay, they want you to find the maximum possible surface area. So basically, when you read the word maximum, so don't rush into conclusions, because you can see it's just how many marks? Just 1 mark. Basically, they are asking you the limiting value, the maximum you could. You don't have to go for dA by dt. If you go do that, it will waste you precious amount of time. Just 1 mark, which means it should be pretty obvious. So how do we find this limiting value? So whenever you see this e to the power, I have given you certain rules, right? So if you have e to the power x, and if you are x, e to the power x, and if e to the power minus x, and if your x limits to infinity, or when you get a very large value of x, we say e to the power x minus x limits to 0. This was explained by using the e to the power minus x graph. This is the e to the power minus x graph, right? Can you see? This is the e to the power minus x graph. So you can see when x limits to, when x is a very large positive figure, the e minus x graph comes closer and closer to 0. So this is the theory behind it. So then to get to do this 1 mark question, what we do here is, now they have told us area equal 80. P is 2.4. 2.4 e to the power 0.15 t divided by 2.4 times e to the power 0.15 t plus 4. They ask you to get the maximum value, or like the limiting value. However, you can see I have now, this would have been quite easy if the x value, if I had e to the power negative power. If my e to the power was a negative, then I can use this rule, right? But now you can see it's a e to the power positive. So when it's e to the power positive, what you need to do is you have to convert it to negative. How do we do that? How do we do that? All you need to do here is divide the whole thing by, divide both up and down by what? E to the power 0.15. You know, if in a fraction, you are allowed to multiply both up and down by the same number. You can even divide both up and down by the same number. So when you do this, what happens? I get here area equals 80 times 2.4 e to the power 0.15 t. Will cut off with this. And then in the denominator you have 2.4 e to the power 0.15 t. Will cut off with the e to the power 0.15 t, because you are dividing. Each term divides, right? The other one, the plus 4 also will divide by e to the power 0.15 t. Are you with me? Each and every term here individually divides by e to the power 0.15 t. Okay, so then what happens in the next step? 80 into 2.4 divide by 2.4 plus this one. You can bring the e to the power 0.15 t as e to the power minus 0.15 t. Okay, I think a better way of doing this is, rather than dividing by e to the power 0.5 t, we could have multiplied it with e to the power negative 0.15 t. That would have been more easier for you all to understand, because to use this rule, I want to make sure that my e to the power is negative, right? To use this rule. So maybe rather than going in this way, to make it worth for 1 mark, okay, you can, now this is your sum, 80 times 2.4 e to the power 0.15 t divided by 2.4 e to the power 0.15 t plus 4. This is what we have, right? So now, you know, if they're asking you the limiting value, you need to have e to the power minus x. You need to have a negative power of e. So then you can see you already have e to the power positive. So what you do is you multiply both up and down. You know, whatever you multiply, you need to multiply both up and down by the same figure. So we can choose to multiply both up and down by e to the power minus 0.15. Right? So then you realize that you're not doing any difference to the sum. So then in here, 80 into 2.4 e to the power 0.15 into minus 0.15 is e to the power 0 when you add the powers. E to the power 0 divide by, here also 2.4 e to the power 0.15 t multiplies with e to the power minus 0.15 t to give you e to the power 0. The other one, 4 times e to the power minus 0.15 t. So you can get the exact same answer as earlier. Okay, this is, I think, faster. And then what you do is, to find the limiting value of area, what do? We send t to the maximum for large values of t. So what happens for large values of t? Your area becomes 80 times 2.4 e to the power 0, of course, becomes 1, right? Divide by 2.4. What happens here? 4 times e to the power minus 0.15 t. So when t goes to infinity, e to the power minus anything. The coefficient, of course, is not a problem here. So e to the power any coefficient of x will go to 0. So basically this is 4 times 0. then you get 80 into 2.4 divided by 2.4, which is simply 80. You could reduce quite a amount of steps here. So you can come from here to here in one go. Okay, so this is the answer. This is the limiting, the maximum value of your area. It's just for 1 mark, so you don't have to do any differentiation here. Okay, so this is the way to get the answer, the easiest way to get the answer. Okay, moving on to question number 5. Figure 1 shows a sketch of part of the curve with the equation y equals 6l and 2x plus 3 minus half x square plus 4. And x values they have given here. Do you see the domain here? They say x values are supposed to be larger than minus 3 over 2. Okay. The curve cuts the negative x-axis at the point P as shown in figure 1. Show that the x-coordinate of P lies in the interval minus 1.25 to minus 1.2. Okay, how do we show that the x value of P lies in between these two values? Substitute these two x values into the x value here and show that. And show that your y values actually have a sign change, because that shows that one x value is behind the given root and the other one is after the root. Okay, provided that your graph is also what? Continuous. Your graph shouldn't be discontinuous. So here we can see we have a continuous graph. The graph is continuing. So let's take here. So I'll take here fx equals 6 times ln 2x plus 3 minus half x square plus 4. Let's input the first one. X is minus 1.25 and get me the value of f minus 1.2. Okay, let's get it. We can type the whole thing in the cal directly here. So we can type here 6 ln 2x plus 3 minus half x square plus 4. So you type the whole thing in the cal and just give the x value. Substitute the x value, the calculator will input the x value for you and get the decimal answer. So then we give calc and give the x value minus 1.25. Okay, you give minus 1.25 and the answer is minus 0.9401. Minus 0.9401. So this is the answer we get from the calc. The next one, again you give calc and give the x value as minus 1.2. And we get 0.21504. So 0.2150. Okay. So we can very clearly see here what there is a sign change. So you can write here there is a sign change and the graph is continuous. And y is continuous. Therefore P lies in the interval. P lies in the interval minus 1.25 to minus 1.2. So make sure you mention all these things for 2 marks. Okay, 1 mark for getting these the values, the y values, and 1 mark for saying about the sign change and you describing about the reason, the sign change reason, and the conclusion. So make sure you write all these things. Okay. Okay, moving on to the next part. The curve cuts the positive x-axis at the point Q, also shown in figure 1. Using the iterative formula, xn plus 1 equal root 12 ln 2xn plus 3 plus 8 with x1 equals 6, find 4dp the value of x2. Okay, so they ask you to input the x1 value here and get x2. So how do we do it? So xn plus 1 equals root 12 ln 2xn plus 3 plus 8. So they have told you x1 is 8. So what do we do here? We need to find x2, which means what? To get a x2, I can replace n with 1. Then I get here n 1 plus 1 is x2 here. Equals root 12 ln 2x1. We replace n with 1 plus 3 plus 8. And now replace the x1 with what? Replace the x1 with 6. So it's just, yeah. Typing in the cal 2 ln 2 times 6 plus 3 plus 8. So get the answer here. Type in the cal. Okay, so I have typed the value in the cal. 12 ln 2 times 6 plus 3 and plus 8. The root of it. The answer is, they want the answer to 4 decimals, right? So 2.36369, which means it's going to be 7 here. 3637. 6.3637 is the answer correct to 4 decimals. Then they ask you in Roman number 2, so make sure you give your numberings correctly. B Roman number 1, B Roman number 2. They say here, find by continued iteration. That means you keep on iterating. The x coordinate of Q give you an answer to 4 decimal places. Okay. So what do you mean by continued iteration? Now normally we use this iteration. So now they say here this iteration is used to find which coordinate, by the way? They say here they use this iteration to find the coordinate of the point Q. Are you with me? So then the first approximation of Q we used was x equal 1, x equal 6. Okay, then we got the second approximation of that as 6.3637. So what do you mean by continued iteration? You keep on iterating, getting x3, x4, x5, and you keep on doing it until what? Until, now they want here 4 dp, until you get iteration where the answer becomes solid at 4 dp. Okay, so now look here, look what I mean here. Now you have already typed the equation in the cal, right? So all you do is, and I got the x2 answer here. So after you come to this point, what you do is you take your cal, take the cursor, move the cursor. Now what's the, to get the next iteration, I need to substitute the x with the answer, right? Now if I want to get x3, basically x3 means to root 12 ln 2 x2, because I replace n with 2. x3 here I have to get x3, I have to replace my x2 here, isn't it? So x2 answer is this. So that x2 answer in its entire form, not just the 4 dp value. The full x2 answer should be substituted here. So then we are not going to do it manually. We will definitely use the help of the cal. What I'll do here is, now the answer is stored in the cal. This answer is stored in the cal, the x1 answer, the x2 answer. Then keeping that in memory, we go here and we replace the x value. Now here I have given 2 times 6, right? So remove the 6 and put what? And put what? Give answer. What does that do? 2 times answer plus 3 plus 8. So then now what the calculator does is it will input the last answer in its memory in place here. And then what happens when you put the last answer in memory, the x2 answer, when it comes over here, that gives you x3, isn't it? So then press equal mark and now we get x3. Do you see? So write down x3 is 6.40. Tell me the answer. So x3, directly write 6.40. We need to make it stable to 40. 6.4082. 8185 is 82. Now what do we do? Now to get x4, I again need to input this value into the answer, right? So do I need to do anything here now? No, just press the equal button. Press the equal button. One button in the cal and you get the next answer change. Do you see? 6.41346, which means 6.4135. Okay, do you see what's happening on here? So you need to keep on iterating until what? Until these the first 4 decimals become the same. So then when you keep on iterating, you come to the root. I want to continue this until the first 4 decimals. When by continued iteration, I must get the first 4 decimals must be the same for a few iterations. So then I got x4. Now again, just simply press what? Equal. Then the calculator will input the answer in place here. The answer. Press equal and I get 6.41409, which means 6.4141. So x5, 6.4141. Is this stable yet? No, it's not stable yet. Continue. Press equal mark again. And now it became again 6.41416, which means x6 is 6.4142, right? Are you okay with it? 6.4142. Then the next one, again press equal and I get 6.4142. Okay, so x7 is also 6.4142. I think it became stable. Can you see? x6, x7 are both the same. You can continue doing. Just continue. Press equal mark many times. 6.41417. I think you can see it's not changing. Do you see? 6.41417. The 5th decimal place has become stable. Can you see? Now when I press the equal mark, each time the last digit is only changing. Okay, so it has become stable. Okay, so there are many more decimals coming here, so the calculator displays only this many decimals, so for that it makes it stable. So anyway, my answer correct to 4dp by continued iteration, so it comes by 7 iterations, 6.4142. You keep on pressing equal in your cal and you get the you get this answer. Okay, so the answer, so at the end of the day, they just want the x value, just give x equals 6.414. It's just 1 mark for this, so you just need to write this answer by continued iteration. That's it. Okay. Okay, moving on to part C. The curve has a maximum turning point at M as shown in figure 1. I think you can see the figure. There's a maximum turning point. So we can kind of like, this is a kind of like an accurate graph. So you can see the X figure here is for the maximum point. It's a positive figure. So anyway, they are asking you using calculus. Using calculus means what? Using differentiation and showing each step of your working clearly. Okay, and showing each stage of your working. Find the X coordinate of M. Okay, so how do we find the X coordinate of M? Obviously, what we do is we take the Y equation and find dy by dx. Make your dy by dx equal to 0, and we are supposed to find the coordinate of X value. They're asking you to find the X coordinate, only the X coordinate. Okay, so then let's get it done. So part C, y equals 6 ln 2x plus 3 minus half x square plus 4. Okay, so then let's differentiate. So we'll take the differentiation rules. So these are my differentiation rules. I've just taken them here so that we can differentiate. These are the rules, differentiation rules. Okay, so how do we use this one? The ln differentiation is, so you can see dy by dx, ln fx is f dash x over fx. So basically your fx value, the inside logarithm part is in the denominator and the differentiation of denominator is in the numerator. So dy by dx is equal to 6 times, what do you get here? 2x plus 3 is in the denominator. Differentiation of 2x plus 3 should be in the numerator, which is 2. Minus half x square. X square differentiation, we don't need any of this, right? So x square differentiation is 2x plus 4. So at the turning point or at maximum, dy by dx is 0. I get here 6 times 2, 12 over 2x plus 3. Here, the 4 will cancel out. Yeah, when you differentiate, the 4 becomes 0. Okay, there is no 4 here. So we get here minus x. Yeah. So then we need to solve and make x a subject. Okay. So then I'll take the minus x to the other side as plus x. 12 over 2x plus 3. Then 2x plus 3 we can take it to the other side and multiply with the x. So what do we get here? X times 2x plus 3 equals 12. Open the bracket. X into 2x is 2x square. X into 3 is 3x equals 12. So 2x square plus 3x minus 12 equals to 0. Do you agree with me? So then we'll solve this. So can you all solve for this? I think this does not give us good answers. We will have to probably use the quadratic formula, right? X equal minus b. So I'll directly input the values. A is 2, b is 3, c is minus 12. Using the quadratic formula, minus b plus or minus square root b square minus 4, a is 2, c is minus 12. B square minus 4ac divide by 2a is 2. So type this in the calc. Can I know the two x values? Exact answer. First, can I have the exact answer? Minus 3 plus root 105 over 4, or x equal minus 3 minus root 105 over 4. So they have told us here very clearly x is supposed to be greater than minus 3.3 over 2, right? Minus 1.5. This is, I think, more than that, is it? Minus 3 minus root 105. So anyway, we can definitely understand that this is not, the negative x value should not be part of our answer because the graph is drawn and given to you very clearly. So your x value should be definitely positive, right? So then we'll take the value here. So this is not the answer. We should only take the minus 3 plus root 105 over 4. So they say to get the x coordinate. So this is it. This is the x coordinate. Okay, minus 3 plus root 105 over 4 is the answer, or you can give it to 3SF. Minus 3 plus root 105 over 4, which is 1.81. If you give it to 3SF, or you can give your answer in exact form. Okay. Question number 6. The function f is defined by fx equals 5x minus 3 over x minus 4. And they have told you here again, x values are greater than 4. Basically, this is your domain. So we only input x values greater than 4. Show by using calculus that f is a decreasing function. Okay. So this decreasing function, increasing function is something you learn in P2 as well. So if it's a decreasing function, it means that for all these x values, I mean, when you input the x values in increasing order, your graph is going down. Your graph is going down. Basically, you have a graph that slopes down. Okay, so how do we show that the function is decreasing? What's the rule? If your y values are decreasing, it means you have a what gradient? We need to talk about with the gradient. If your y values are decreasing, it means your gradient, your dy by dx, your f dash x is negative. If your gradient, if your dy by dx or if your f dash x is positive, the positive gradient means your function is increasing. That means your values, y values are increasing. While if you have a negative, if your f dash x values are negative, or if your gradient is negative, it means your graph, the y values are decreasing. Okay, so that's the rule. This is something you even learn in P2. So then they are asking you show by using calculus that f is a decreasing function, which means what? Which means for all x values, your y values are decreasing continuously. So then how do we do it? We need to find the f dash x value and show that for all x values, our f dash x function is actually a negative answer. So let's get that f dash x. So fx equals 5x minus 3 over x minus 4. Okay, how do we differentiate something like this? What's the rule that we need to use here? So I have brought my rules here again. So differentiation rules. What's the rule we need to use here when you have numerator and denominator? We can go for the quotient rule. Yeah, so fx over gx. So this is the quotient rule. Let's use it. To get f dash x, what do we do? The denominator gets squared, right? So x minus 4, you square it, and then denominator times, follow the rule, denominator times differentiation of the numerator. So 5x minus 3 differentiation is 5 minus fx is 5x minus 3 into g dash x differentiation of the denominator is 1. Okay, is that clear? Okay, so apply the rule here. Okay, the denominator stays while the numerator differentiates. 5x minus 3 differentiation is 5 minus, then the numerator stays while the denominator differentiates. X minus 4, x differentiation is just 1. That's all we have. Then simplify f dash x. What do we get here? Open the bracket with 5, 5x, 5 into minus 4 is minus 20. So in here, be careful when you open the bracket, your bracket opens with what? Not just 1, but with minus 1. So open with minus, the 1 of course will not make any change. Minus 5x and minus into minus is plus 3 over x minus 4 square. Are you with me? Let me remove these rules. So then what do we get here? F dash x equals 5x minus 5x will cancel out. Minus 20 plus 3 is minus 17. Minus 20 plus 3. Minus 17 over x minus 4 square. Okay, now look at this. Now, we need to show that by calculus, that is by differentiation, that f is a decreasing function. So I got the gradient, the f dash x function. And then you need to check the gradient function when you input x values. Now your gradient has come in terms of x. So what do you see here? Regardless of what you use for x here, so then you what you use for x in a sense, we have told you clearly x should be greater than 4. So you don't use any other value. So for all x values greater than 4, say you use 5 or 4.1, 4.5, anything. Or x is 10, x is 1000. What do you see here in this graph? This is a square function, right? So basically always it produces a what answer? Positive. Your denominator is positive. Regardless of what x value you use, your denominator is positive. And then minus 17 divided by the positive denominator is negative. End of the day, this entire bracket always produces a negative answer. which means your gradient x is negative for all x values greater than 4. Do you see? So you can write your f dash x is less than 0 for all x greater than 4, isn't it? So therefore f is a decreasing function. Give reasons and do it properly. Therefore f is a decreasing function. Next one, part B, they ask you to find f inverse. How do we find f inverse? So you take your graph y equal 5x minus 3 over x minus 4. To find inverse, we switch x, y and make y the subject, right? So switch x equals 5y minus 3 over y minus 4. Then make y the subject, x times y minus 4, 5y minus 3. So I get xy minus 4x equals 5y minus 3. Let's make y the subject, xy. I'll take the 5y here and take the minus 4x there. So I get xy minus 5y equals 4x minus 3. Y times x minus 5 equals 4x minus 3. So I get here y equals 4x minus 3 over x minus 5. Basically y means the f inverse. F inverse x equals to 4x minus 3 over x minus 5. So whenever they ask you to find f inverse, okay, when they ask you to find f inverse, there's one thing. This is not just only finding the inverse value. There's one more additional thing that you must always do whenever they ask you to find the inverse function. What is it? You must state its domain. Okay, so 2 marks for this and 1 mark for stating the domain. So let's get the domain as well. Okay, so to get the inverse, you could also, not do the switch, and you could do this in the original form and just make x the subject. You could do that, and at the last point, like, some of you might be used to doing it in the method where you make actually to get the inverse function, where you make x the subject. And then if a person makes x the subject, you would go through this exact same steps and end up getting x equals 4y minus 3 over y minus 5. So this is also okay, and then at the end you can switch back. You can switch x, y and come to this answer. That is fine. Okay, now the thing is how to find the domain. Okay, because as I told you, f inverse is not complete until you get the domain. Okay, so to get the domain, what I normally do is just 1 mark, but the thinking process is a little bit tough here. So what I do here is I do a quick sketch of the graph. Okay, so what we do here is, these are two asymptote graphs, right? So basically the original graph was y equals, what was it? Y equals 5x minus 3. Y equals 5x minus 3 over x minus 4, right? So it's an asymptote graph. Basically an asymptote graph is a graph that goes, a discontinuous graph that goes like this around its asymptotes. Either it goes like that or it goes like this around its asymptote. So this is the general shape. Okay, so basically what you do here is they have given you, we already have the y in terms of x function, right? So looking at this, an asymptote is a place where we get math error. So when do we get math error in a fraction? When the denominator becomes 0. So what x value makes a denominator 0? 4. So then what you do is in your graph, in your quick sketch, make a quick sketch. X equals 4 is one asymptote. X equals 4 is one asymptote. Okay. Then it's an asymptote graph, which means there's not only an x asymptote, there is also a y asymptote. How do you get the y asymptote? You get the y asymptote when you do the inverse graph, because in the inverse graph you find x in terms of y. So in this graph, what's the asymptote that makes the denominator 0? Y equals y minus 5 means to make the denominator 0, it should be y equals 5. So which means y equals 5 is your other asymptote. Okay, so this is the other asymptote. Okay, so to get the domain of f inverse, what I do is I take the original graph. Remember, asymptotes are the places where your denominator becomes 0, because when the denominator of a fraction becomes 0, that's when you get math error. So when you have x minus 4 here, it means x equals 4 gives you 0, right? The denominator becomes 0. So x equals 4 is one asymptote. and the other graph, in the inverse graph where you have x in terms of y, that gives the other asymptote. So y minus 5 is the denominator, which means y equals 5. When you put y as 5, 5 minus 5, you get denominator 0 again. So y equals 5 is the other asymptote. Now, in your quick sketch, so these are the two asymptotes. Now you need to figure out whether your graph goes this way with the two asymptotes or whether it goes the other way around the asymptotes, whether it goes in this manner or whether it goes in the other manner. How do we decide it? Just check with one coordinate. Normally I check with the coordinate when x is 0. Can you input x as 0 here? What do we get? Type in the cal, just give x as 0. We need a quick sketch. So we get here 5 into 0 is 0 minus 3 over 0 minus 4. What do you get here? 3 over 4, which is positive, and it's 0.75. This is the place where the graph cuts the which axis? When x is 0, that's the place where your graph cuts the y-axis. Okay, so this is the y-axis, so it's cutting at 3 over 4. So then your graph needs to go through 3 over 4, and also it needs to make the shape that I told you. So what's the way to draw it? So you take it like this. Do you see the shape? Which means automatically the other side should come in this manner. And now they have told you that they have given you the domain. They have told you your graph is only supposed to be drawn for what? X values greater than 4. Can you see? So for x values greater than 4, what's the set of y values we have? So for x values, so now here basically I have drawn the fx graph. Okay, by the way, I have drawn the fx graph. I didn't, not the f inverse graph. I drew the fx graph here. So then now after taking this graph into consideration, I have taken only the x values greater than 4, which means what? I am only considering this part of the graph. Only this part. So this part is completely removed. Do we need this? No. So you could just take the erase and just remove it. You could just remove this part. So this part of the graph can completely be removed. Are you with me? So this is the only part of the graph we need. And now tell me the range. What's the range of this part? Where are your y values varying from? Your y values are what? Greater than 5, because this is an asymptote. This value, this will go up, right? This keeps going up. So then it means your y values, the domain, for this domain, the range is what? Y greater than 5. Are you with me? For the domain x greater than 4, the range is y greater than 5. Now we have found f inverse. So for the f inverse, just to get the domain, the domain of f inverse is what? Domain of f inverse is equal to the range of fx. The domain of the inverse graph is equal to the range of the original graph. So what's the range of the original graph? Y is greater than 5. However, when you're writing domain though, what do? You don't write y greater than 5. You must make it x. So here for the f inverse, you must write one more thing here. You write the domain as x greater than 5. How did I get x greater than 5? Once again, the domain of the f inverse is the range of the fx function. So range of my fx function was y greater than 5. So anyway, when you're writing domain of the inverse, you write the exact same thing but change y into x. Okay, so these are theories that you have learned in the P3 book. Okay, so let's move on to part C. Show that f of fx equals ax plus b over x plus c. Okay, shall we find f of fx? And they ask you to find where a, b, c are constants to be found. So let's get it. Part C, fx is given as 5x minus 3 over x minus 4. So let's get f of fx. What's f of fx? You replace what? The x with, you replace your x with fx. Are you with me? So you replace your x with fx. So I get here 5 instead of x, I use fx. 5fx minus 3 over fx minus 4. This is what we mean by f of fx. Replace the x with fx. Okay, can all of you see? We replace the x with fx. So all the x values here are replaced by fx. Okay, now let's try to input the values. So 5, now we know fx, right? So then we need to replace now the fx as what? 5x minus 3 over x minus 4. So 5fx minus 3 over fx. fx minus 3 over x minus 4. Minus 4. Can you see what I did here? I replaced fx with what we have here, 5x minus 3 over x minus 4. Again, fx is 5x minus 3 over x minus 4. Okay, now how do we simplify? To do simplifications like this, I prefer to write this as a division. 5 times 5x minus 3 over x minus 4. Over x minus 4 minus 3. So this one divide by 5x minus 3 over x minus 4 minus 4. And then what do? We take the common denominator. We take the common denominator here. So common denominator will be x minus 4. So let's simplify here. So 5 times 5, 25x minus 15. Common denominator will now be x minus 4, which means what? The minus 3 will multiply with x minus 4. Divide by here also. Common denominator is x minus 4, which gives me 5x minus 3. Here, of course, again, the minus 4 will multiply with x minus 4, isn't it? So now, of course, we have it in the simplified fractional form. So can you all simplify here? Minus 3x and plus 25x. Shall I do it immediately? What do I get? 25 minus 3 is 22x. And here, minus 3 into minus 4, be cautious. Minus 3 into minus 4 is plus 12. So plus 12 and the minus 15 is how much? Plus 12 and minus 15 is minus 3 over x minus 4. Okay, I'm reducing a number of steps here. Shall I turn division to multiplication? Here itself, and then x minus 4 comes up and the denominator we get, shall we simplify that also? So I get here what? Minus 4 into x is minus 4x. Minus 4x plus 5x is plus 1x. Do you agree? And here I get the next one. Minus 4 into minus 4 is plus 16. Plus 16 minus 3 is plus 13. This is okay? Okay, so then we have the fractions like this. So now what happens? You can see the x minus 4 will cancel out with the x minus 4 and my f of fx becomes 22x minus 3 over x plus 13. This is f of fx. Okay, is this clear? This is the answer for C part 1, right? The answer for C part 1. Do the numbering correctly. C part 1. Okay, then they ask again in part 2, deduce the range of f of f. So f of f means what we found over here, right? So again, whenever you see a graph like this where you have x in the numerator and x in the denominator, what does it mean? It's definitely a reciprocal type graph. So definitely it's a reciprocal type graph, and we know they are asking you to find the range of the fx values. Okay, so let's go to find the range. Okay, so for the reciprocal graph, let's draw a quick sketch because they just want the range and you will not get marks for any of these sketches. But to get the range, we need to have an idea of how the graph is moving. So basically, when you see 22x minus 3 over x plus 13, you directly know that what? When the denominator becomes 0, that gives you one asymptote. So who is one asymptote here? Who is one asymptote here? Definitely. X plus 13 in the denominator means what makes it 0? X equals minus 13 makes the denominator 0, which means x equals minus 13 is one asymptote. Okay, x equals minus 13 is one asymptote. Okay, and then how do I get the y asymptote? One method to get the y asymptote is now this is your y function. Basically, you take your y function as 22x minus 3 over x plus 13. The way to get the y asymptote, one method would be where you actually make x a subject. Like we did earlier. In the earlier question, we found the f inverse, which means we made x a subject. And then you got the answer in terms of y, and then you found the denominator that you got in terms of y, and you found the y value which make the denominator 0. Right? So in here, you could do like that, or there is another shortcut that you could use. So look at this shortcut. I was giving you certain infinity rules in the previous sums also, but are you aware of this rule? When x goes to positive infinity, are you aware of what happens to 1 over x? So again, 1 over x graph is something that goes like this, right? The reciprocal graph. When x value goes to infinity, 1 over x graph goes to 0. So this is one way that we can use to find the y asymptote, a technique that we can use. So when you get like this, if you're not comfortable with this, you can definitely make x a subject and do. Okay, so what I'll do here is I'll multiply or I'll divide everyone with x. So what I'm doing, I'm dividing everyone with x. What do I get here then? 22x divided by x is 22. Minus 3 divided by x is 3 over x. X divided by x is 1 plus 13 divided by x is 13 over x. Are you with me? Now we'll send x to infinity. What happens when x goes to positive infinity? Y equals 22 minus 3 over x. 1 over x becomes 0, right? When x is a large figure. So minus 3 over x becomes 0. This is 1 plus 13 over x also. You have x in the denominator, 1 over x type. So that also becomes 0. Basically, your y asymptote will be 22. Either you could do that, or you could do the thing we did earlier, where I made x a subject. So any of these two methods are fine. Just do one thing. This method is shorter, where you can get the asymptote really fast. Okay, or else you can take x plus 3 to the other side. Okay, this is the alternative. You get xy plus 3y equals 22x minus 3, and you make x the subject, isn't it? So 3y plus 3, I'll take the 3 here and I'll move the xy to the other side. 22x minus xy. Now take x out. Then I get here 22 minus y. Are you with me? So I get here x equals 3y plus 3 over 22 minus y. Now you can see again, what's the y value that makes the denominator 0? Y equals 22. Can you see when y is positive 22, the denominator becomes 0 and you get the math error? So that either you could use this or use this. Okay, so then I end up getting here y equals 22 as my second asymptote. This is the second asymptote. Okay, now where do we need to, now you need to realize here what your graph is either going to be like this around the two asymptotes, or it's going to be this shape, one of the two shapes around the two asymptotes. Either it's this or it's this. So we need to figure out which one is the correct one. How do we do that? Take x value, substitute. So we'll input x as 0. What do you get when you input x as 0? So when x is 0, what's the y value we get here? Y equals 22 times 0 is 0 minus 3 over 0 plus 13. What do we get here? Minus 3 over 13. So that means when x is 0, y is minus 3 over 13. So that gives me an idea of where the graph moves, right? So it's moving like this. Can you see? Which means the other part of the graph goes like this. Okay, so now to get the range. So how do I get the range? They have specified as the domain, right? What's the domain they have given? The domain was to get the values of what? For x values greater than 4. This was given originally in the graph. If x is greater than 4. So therefore, which I need to only consider what? X values greater than 4 only from this point. So actually all of these parts, do I need it? No, none of them are needed. Or no, none of them are needed. So basically I can erase all of them. I can erase all of these parts of the graph. I don't need, I only need from this point. So then the graph only starts at x equals 4. And you get your graph at x equals 4 and it goes to the asymptote. Okay, do you see what's happening here? So what's your range? Can't you say the range of f of fx? So what's the lowest value in your f of fx? You'll need to find this y value. How much is this y value? We input x as 4 into this equation. So input x as 4, f of f4. What is it? 22 times 4 minus 3 over 4 plus 13. How much is it? When x equals 4, what do we get? How much do we get? Quickly. 5. So I get 5, which means this value is 5. So the lowest my graph goes is 5, the y value, and the highest it reaches is what? It goes towards the asymptote, right? So the highest y value we have here is 22. Okay, so then your f of fx is greater than 5. We don't put the equal mark here because at 4 we don't have the equal mark. Your domain doesn't have equal mark at 4. So we don't need to put the equal mark, and since the other side is also an asymptote, we don't put the equal mark to that side as well. So your range is the y values are greater than 5, less than 22. Okay, so they just need to say this. Okay, you don't get marks for any of these workings. Just need to get this. Okay. Okay, next we move on to question number 7. Figure 2 shows a sketch of part of the graph with the equation y equal fx, where fx equals half modulus 2x plus 7 minus 10. State the coordinates of the vertex v of the graph. Okay, so the coordinates, obviously, like you need to write the xy coordinate, one mark for x, 1 mark for y. Okay, so what's the easiest way to get the equation, the coordinates of this vertex? Basically, the easiest way to get the coordinates of the vertex would be where you think of this graph, where you take this graph as a series of transformation. Okay, so the original graph you have is modulus x, then you have 2x, or you can say think of the original graph as 2x plus 7. Okay, so in the 2x plus 7 graph, you should know. So I don't want to go into a lot of details because it's just 2 marks. You should know when you have a modulus graph of this form, always the point is on the x-axis, because in these types of graph, your graph doesn't go below the y-axis. And you should know in this type of graph, the point is where. If I just ask you to draw y equal 2x modulus 2x plus 7, where would this point be at? What would be the coordinate of this point? Yeah, you make this part equal to 0. And your point would be what? 2x plus 7 equals 0. Your point would be at minus 7 over 2. And then outside you again get a half here. That means you multiply the y coordinate with 2. And then the minus 10 will affect the y coordinate. So you take the entire graph down by 10 units. So basically what you need to realize here is this v value here. The v coordinate here is going to be minus 7 over 2, the x coordinate. The y coordinate is simply going to be minus 10. You can just look at the graph and get it. Okay, that's all you need to do here. You don't need to show, there's nothing to work here. I mean, some of you might consider using simultaneous equations here, getting the equations of the two graphs and working out. But we don't need to go for that here. Just for 2 marks, it's not worth it. So what you do here is you take the x point from the inside modulus part and the y point from the outside. Okay, so basically the coordinate of the turning point, the coordinates of the vertex of the graph would be at where? Part A answer is the coordinates of the vertex would be at minus 7 over 2, comma minus 10. Okay. Okay, just to answer a question here again. So for example, if you have a graph, I just wrote a random graph here. If you want to find the vertex coordinate here, what do you need to do? Basically, you take the inside of the modulus part, x minus 5, and make it equal to 0. What do you get then for the x coordinate of the vertex? X equals 5. And the y coordinate, it's not affected by this multiplication by 3, but it's affected only by the addition 3. So not this 3, but the other. The y coordinate will be the plus 3 that comes from here. So the vertex coordinate in this case would be 5, 3, just to give you an idea. Okay, so this value here, the value in front of the modulus makes no effect on the y coordinate. Okay, is that clear? Just to give you a rough idea. Anyway, that's not what we need to do here. Let's move on. This. Okay, so this is just the general idea again about the vertex. Okay, right, let's move on. Solve using algebra. Half modulus 2x plus 7 minus 10 is greater than or equal 1 over 3x plus 1. Okay, so they want you to solve it using algebra. Okay, so how do we find this? Okay, so basically the half modulus 2x plus 7 graph is already drawn for us, right? Okay, so can we get the two equations for that modulus graph here separately in part B? It's 4 marks. So I get here y equals half. First, shall I take the positive part of the modulus? Half 2x plus 7 minus 10. What do we get here? Half into 2x is, what do we get? X. Half into 7 is 7 over 2 minus 10. Can I have the simplified answer for y? 7 over 2 minus 10 is? Yeah, minus 13 over 2. Simplify. So y equal x minus 13 over 2. So basically you need to now identify from these two graphs which is which. So I identify y equal positive 1x means a positive gradient. Here this is the graph with the positive gradient. So this graph should be y equal x minus 13 over 2. Get the other graph as well by considering the negative gradient. The negative part of the modulus y equal half. Inside bracket it's negative 2x minus 7. The negative and minus 10. Minus half into minus 2 is minus x. Minus half into 7 is minus 7 over 2. Minus 10. How much do we get? Y equal minus x minus 27 over 2. So that should be the other graph. This one, negative gradient graph. Okay, so have an idea of your graphs because we need to find the range. Okay, then the next thing you do is, kind of like they ask us to solve using algebra. So definitely I will be solving these equations simultaneously, but I need to kind of have a rough idea how this graph looks. Whether this graph 1 over 3x plus 1, whether it intersects with both the graphs or whether will it intersect with only one graph, because that can only be seen if you kind of draw it on top of this. Otherwise, you wouldn't be able to see whether the graph meets both the curves or whether it only meets like one curve like this. Okay, so otherwise you would go wrong if you go to solve it with both. So let me check on that. 1 over 3x plus 1. How do we sketch that graph quickly? Can I have these x values here? Y equal minus x minus 27 over 2. What would I get for the x starting point? When y is 0, what's the x starting point? Okay, so so I was asking the x value here, right? Okay, we can actually use another technique here. Shall I, without drawing the graph, shall I go for the other technique? Yes, we'll go for that. I think it would be a lot easier for y'all. Look at part B. Okay, so I got my two equations, right? I got the modulus part of each of these equations. Let me do it like this. So let's use the positive modulus here. Okay, so the first one is half modulus 2x plus 7 minus 10. We are supposed to solve where it's greater than or equal 1 over 3x plus 1. Right? So then I solve this equation when the modulus sign is positive. And what did I get here? I got x minus 13 over 2, right? Okay, now the thing here is this. This method is, you can just do it like this, but there is an issue whether the graphs actually meet or not. Whether the graph 1 over 3x plus 1 will meet both the curves or whether it only meets one. Okay, so to check on that, what we do is, okay, first you solve and get your answer. What do we get here? X, the minus 1 over 3x, let's bring it over here. Bring the minus 13 over 2 to the other side. X minus 1 over 3x greater than or equal 1 plus 13 over 2. So what do we get here? X minus 1 over 3 is 2 over 3x is greater than or equal 13 over 2 plus 1 is 15 over 2. Are you with me? So what do we get for x values here? X is greater than or equal what? 3 times 15 is 45. 2 times 2 is 4. I get like this, right? I get an answer like this. However, even though you get an answer like this, do not immediately take this as an answer, because we need to be sure, we need to verify whether this answer actually, whether the graph actually cuts and we get these cutting points, whether we get all these, whether this is really valid. We need to check on the validity of this. So how do we check on the validity of x greater than 40 or equal 45 over 4? Okay. So how do we know whether this is a valid range? What you do here is x greater than or equal 45 over 4. So take actually a value greater than 45 over 4. So what is 45 divided by 4? So I get here 11.25, right? So what you do is take a x value greater than 11.25. We need to actually check on this. Take any value greater than, because here it says x value is greater than or equal 11.25. Take any x value greater than 11.25. Take any. This shall we go with 12 or go with 15 or 20 or anything. Just take any x value greater than this given value and let's substitute that into what? Let's substitute that into this given inequality and see whether this inequality is true. If this inequality is true, then this region is correct. But if this inequality doesn't hold, then this is wrong. Okay, so we need to double check on that. You must make sure to double check on it. Otherwise, you need to go with the initial method I was saying, where you draw the graph and check on the region. So I think more than drawing the graphs and checking on regions, using this is a lot easier. So shall we input a value? Let's input the x value and check. Half 2x plus 7 minus 10. Input x as 12. Input x as 12 and check on this. Shall we use x as 12? Please use x as 12 and get me the answer. Half modulus 2 times 12 plus 7. So this needs to be checked. What do we get here? 2 times 12 is 24. 24 plus 7 is 31, right? 24. 24 plus 7, 31. Half, so modulus 31 is directly 31. Minus 10, how much is it? 11 over 2, 5.5. So check on the other side now and see whether this inequality holds. Input x as 12, we used x as 12. 1 over 3 into 12 plus 1. So 1 over 3 into 12 is 4. 4 plus 1 is 5. So this is 5.5 greater than or equal 5. Is this correct? Yes, which means this is actually an answer. Which means this is an answer for your solution. Okay, so now similarly, do this for the other one as well, for the negative mark of the modulus. Okay, and check, also make sure you check on its validity. So half, I actually got the answer here. Half modulus 2x plus 7 is minus 2x minus 7 minus 10 greater than or equal 1 over 3x plus 1. So this part I simplified here. So we get here minus x minus 27 over 2 greater than or equal 1 over 3x plus 1. Take all the x terms to one side. I'll take the minus x here and I'll take the plus 1 here. Minus 27 over 2 minus 1 greater than or equal 1 over 3x plus x. So what do we get here? Minus 27 minus 29 over 2. 1 over 3x plus x is how much? Sorry, 4 over 3 x, which gives me x is less than or equal what? How much do I get here? 29 times 3 is, how much do I get here? Minus 87 over 4 times 2 is 8. So minus 87 over 8. Okay, so now again check on this and see whether this actually is correct. So minus 87 over 8 is actually how much? Minus 10.875. You are supposed to use x values lesser than or equal to minus 10.875. Tell me x value who is lesser than minus 10.87. Minus 11, minus 12. So the minus value is, think of the number line. It's not minus 10. Minus 10 is bigger than minus 10.875. Okay, so in the number line, minus 10, minus 11 is behind. Right, so you can use minus 11 or minus 12 or minus 20 or minus 100, anything. Just use any value that is less than this value and check whether this inequality is satisfied. So this you could do as your rough working. So anyway, I will use x as what? Minus, what should we use? We can use minus 11 or minus 12. Shall we use minus 11? Minus 11. Plus 7 modulus minus 10 greater than or equal 1 over 3 times minus 11 plus 1. Get the value of one side, half. What is the value inside the modulus? 2 times minus 11 is minus 22. Minus 22 plus 7 is minus 22 plus 7 is minus 15, right? And minus 10. So get the value here. Modulus of minus 15 is what? Plus 15. So I get here half times positive 15 minus 10. Get me the answer here. So 15 minus 15 over 2 minus 10 minus 20, plus minus 5 over 2. So check whether this inequality holds on the other side. Minus 11 over 3 plus 1, how much is it? Minus 8 over 3. So is this correct? Check on the figures. Minus 5 over 2 is minus 2.5. How much is minus 8 over 3? Minus 2.67. So is this correct? Minus 2.5, you must know minus 2.5, minus 2.6 is going to be behind, right? Because you get the minus 3 like this way. Minus 2.1 here, minus 2 here. Yeah, this is correct, right? So this inequality is correct, which means the answer that we got for the previous inequality is also true. So make sure you double check on this. Otherwise, you need to draw the graph and check. Make sure you double check on this. Otherwise, sometimes the ranges that though you get the answer here, that range might not actually be part of your answer. Okay, because sometimes the modulus graph doesn't intersect with both. Here the 1 over 3x plus 1 graph intersects with both. Okay, so you need to make sure that you double check with the inequality to see whether this given range is actually valid. Okay, so these are the two answers. At the end of the day, our range is x is greater than or equal 45 over 4. Or x is less than or equal to minus 87 over 8. Right? X is less than or equal. The mouth is closed. Is this clear? So one more thing here, when you are substituting, do not give the boundary value of 45/4 into these two equations, because if you do give 45/4, both of them will actually become equal and you cannot check on its validity. So make sure you give a value in the range, above 45/4. Here you give a value less than -87/8. Okay, so these are your rough workings. These do not need to be shown. So this is what they need to see. Okay, let's move on to the next part. The next part, they ask you sketch the graph with equation y equal modulus fx using the coordinates of the local maximum point, stating the coordinates of the local maximum point and each local minimum point. Okay. So they ask you to sketch the modulus fx. So fx graph is drawn here. What happens when you sketch the modulus fx? So how does the modulus fx graph look like? You know, in the modulus graph, it doesn't, basically all your y values are supposed to be what? Positive, right? You don't have a graph that goes below the x-axis. The y values are all positive. Modulus makes everything positive. So how do we convert this graph? The part of the graph that goes below the x-axis, basically this v part here, down here, this will be completely what? Reflected upward. So it will reflect like this, the other side. Are you with me? So you need to just sketch this as part C, and you need to give, they ask you to find all the local maximum points and these two minimum points. Okay, so shall we get those two minimum and maximum points? So first sketch them, sketch the graph. So what happens here? I think we need to get these cutting points because we need all the minimum points here. So can you all get me this cutting point? Because this part of the graph comes like this, right? Yeah, how much is this when x is equal to 0 in this graph? When y equals 0, what do we get? 0 equal minus x minus 27/2. I get here x equals minus 27/2, which means this point is minus 27/2. Stating the coordinate, so give it as a coordinate. And then the v, the v point comes. Now we got the v point coordinate as minus 7/2 minus 10, right, in part A. So when you flip it up, what happens? This part goes up, isn't it? So this coordinate should be what now? This part should be what now? The x coordinate doesn't change, right? So x coordinate is minus 7/2. The y coordinate is plus 10. That's the most important thing. The negative 10 becomes positive 10. So again, the next part of the graph is where the v comes meets down here. So that part, you take it down over here. How much is that value? So make x0 here in this graph. When x equals 0, not x equals 0, when y equals 0. When y is 0, 0 equal x minus 13/2, which gives me x equals 13/2. So this cutting point. So this cutting point is 13/2, comma 0 if I give the coordinates. Okay, and then the other part of the graph will continue in the normal way. So you get kind of like this W shape. Okay, can you understand? And they ask you to find the coordinates of the local maximum and the local minimum point. So I have written these are the two local minimum points, minus 27/2 and 13/2, and the local maximum we have here is minus 7/2. Okay, so local to this point. Okay. Question number 8, a dose of antibiotics is given to a patient. The amount of the antibiotic x milligrams in the patient's bloodstream T hours after the dose was given is found to satisfy the equation logarithm of x to base 10 equal 2.74 minus 0.079 t. Once again, what is this? The x is the amount of the antibiotic in milligrams in the patient's bloodstream T hours after the dose was given. It's important you understand what the variable is. So x is the amount of the antibiotic in the bloodstream T hours after the dose is given. And so it's found by using this particular equation. Show that this equation can be written in the form x equals p times q to the power minus t. Okay, how do we get it into this form? What do we do here? Part A, how do I simplify? Basically you can see they have made x a subject, right? They have made x a subject. How do I make x a subject in this equation? What is the process in making x a subject? Now you can see x is with a logarithm, right? So how do we remove the logarithm? Do you remember the rule converting log to index form? So what is the rule in converting log to index? So logarithm of c to the base a equals b. What's the index form? We write a to the power of what? A to the power of b equals to c. This is something you learn in P2. Okay, take this to the power of b equals to c. So let's get the answer. So here when I convert to index form, this 10 is the c value, the a value, the base here. So what do I get here? 10 to the power 2.74 minus 0.079t equals to what? Equals to this x. Okay, so now we need to get it into this format. I still did not, though I have x as subject now, it's still not in the correct format. How do I separate this? 10 to the power 2.74 multiply by 10 to the power minus 0.079t. Is that clear? Yeah, so then they want, still it's not over, right? Where P and Q are constants to be found. So they want actually this to be given P Q to the power minus T. So you don't have any coefficient for with the T, right? Do you see? Only minus T, no, not minus 0.079. So how do we separate that out? How do we fix that part? 10 to the power 2.74 into, how do I fix this? Because the show that has only q to the power minus t. So what's the q value here? 10, not only the 10 to the power, no, we need minus t to be seen as the power. So 10 to the power 0.079 in bracket 10 power minus t. Do you see this? Because brackets and powers, the powers multiply. And I end up getting still this. So then my q value in its entirety is 10 to the power 0.079. This is entirely q. Okay, and p is 10 into 2, 10 to the power 2.74. So they are saying where p and q are constants to be found, give the value of p to the nearest whole number and the value of q to two significant figures. So get me the answer of p and q. P should be to the nearest whole number. So this is p. 10 to the power 2.74 is p, right? Can you all make it to the nearest whole number? Okay, so type it in the cal. How much? 550. Do I need to show it? You just need to type 10 to the power 2.74. And you get here 549.54. So basically when you round off to the nearest, they want it to the nearest whole number. Nearest whole number will be 550. Q value, they want it to two significant figures. So get the answer to two significant figures. So Q equals 10 to the power 0.079. Get that as well. 10 to the power 0.079. What do we get? 1.199. So when we make it to, they want it to how many? Two significant figures. So to two significant figures, it will be 1.2. Just 1.2. So Q figure is 1.2. Okay, is this clear? Moving on to part B, with reference to the equation in part A, interpret the value of the constant P. Okay, so interpret means you have to give some meaning behind this P value. So we found P value as 550. So you need to give a meaning, like a proper meaning for this P value. So they are asking you to use the reference with part A. Okay, so how do we refer this part A with this model, and how do we get like exactly what P is, exactly what this 550 is by using part A? So normally when they give you a question like this to interpret the value by using the model, normally what we do here is sometimes, we use this t value. Normally for t, sometimes we work with 0, sometimes we work with t equal 1. So basically here t equals 0 will work. Why? Because you can see when t is 0, what happens? When t equals 0, do you see we get x equals p times q to the power 0, which gives me what? Q to the power 0 is 1, which gives me x equals p. So what does that tell you about the p value? P is the amount of what? X is the amount of antibiotics, right? So then that tells you what? P is the amount of antibiotics in the patient's bloodstream. At what time? At time equals 0 means at the beginning. So you can say P is the amount of antibiotic in the patient's bloodstream in the beginning. Okay, so the patient's bloodstream at the beginning. Okay, then the next part, they say here when a different dose of the antibiotic is given to another patient, okay, when a different dose of the antibiotic is given to another patient, the values of x and t satisfies this equation. X equals 400 times 1.4 to the power minus 3. Use calculus to find the two significant figures, the values of dx by dt when t equals 5. Okay, so what do you need to do here basically? Get dx by dt, differentiate. So 400 times 1.4 to the power minus 3. So how do we differentiate 1.4 to the power minus 3? Basically, I'll take my differentiation rules here. So I think we need to go with rule number 6 here, right? Can you see? We'll go with rule number 6. Let's differentiate. Rule number 6, because you have 1.4 constant to a power of t. So here the constant to the power of fx. This is what we should use. So when we differentiate dx by dt equals 104 equals 400 into 1.4 to the power minus 3. When you differentiate according to this rule, what do we get? 1.4 to the power minus 3 will be 1.4 to the power minus 3 into ln 1.4 into differentiation of the f dash to the power. Differentiation of minus 3 is minus 1. Because fx here is the power, our power is minus 3. Minus 3 differentiation is minus 1. Just follow the rule. And then they ask you to find a 2SF when t equals 5. So when t equals 5, get me the answer. Dx by dt, let me rearrange. This is 400 into minus 1 is minus 400 into 1.4 to the power minus t is 5 times ln 1.4. So type the whole thing in the cal and tell me the answer to two significant figures. 1.4 to the power minus 5 into ln 1.4. So I get minus 25.0247, which when we round off to two significant figures, we get dx by dt is minus 25. Okay, so this is the answer for part C. Question number 9. In this question, you must show detailed reasoning. Solutions relying entirely on calculate technology are not acceptable. Okay, so let's do this one. Roman number 1. Solve for x greater than 0, less than or equal 5. The equation 2x square x minus 3 tan x equals 2. Okay, how do we solve something like this? Now the thing is, if you want to solve this equation, either it should be entirely in sec or it should be entirely in tan. You can't have sec and tan. So what's the identity that we use? 1 plus tan square x is sec square. Do you remember this inequality in P3? The identity in P3? So what we do here is we can replace the sec square with what? 1 plus tan square. So replace the sec square with 1 plus tan square. So I get here 2 times sec square is 1 plus tan square x minus 3 tan x equals to 2. Open the bracket. What do we get here? 2 into 1 is 2 plus 2 tan square x minus 3 tan x equals to 2. So this is actually what? A quadratic equation in tan. So 2 tan square x minus 3 tan x and 2 will cancel out, isn't it? So that means I can factorize taking a tan x out. And I get here 2 tan x minus 3. So I get two options here. Tan x equals to 0 or 2 tan x minus 3 equals 0. Okay, so then they have given you the range to solve. Tan x, you're supposed to solve in the region between 0 to pi, the range. Okay, so what are the tan values where we get tan 0? You could consider the tan graph or you could do all silver teacups, any of the two options. So where do we get tan 0 in the tan graph? In the tan graph, we get tan 0 at 0, right? 0. And again, I think we get at tan 90 and minus 90, we get the math error, the asymptote. And again, tan 0 comes at pi, right? Is it? And pi. And pi is 0. Do you see this? Okay, so we get here the x is 0 for tan x equals 0 when x is 0 or when x is pi. Okay, but they have, I think you can see in this range here, they have told x is greater than 0. The equal mark is not there. And less than or equal pi is there, which means what? From this solution, I can remove the 0 and the answer I get from here is x equals pi. Are you with me? Okay, then the next one, 2 tan x equal minus 3. So I get here 2 tan x equals to 3, which gives me what? Tan x equals to 3 over 2. So get me tan inverse 3 over 2 and choose the quadrants where tan is positive, all and tan, first and fourth quadrant. But I don't need to go for the fourth quadrant since my range is only from 0 to pi. So choosing the quadrants where tan is positive, it's only the first quadrant I should go with because the other first quadrant gives a answer bigger than pi. Okay, so what is tan inverse 3 over 2 in radian mode? Tan inverse 3 over 2, right? Gives me 0.982793. So what is the answer they want? For 3 significant figures. So x equals 0.9827, which means 983. So final answer altogether 0.983 to 3 significant figures. Do they want everything? Giving the answer as appropriate to 3 SF. So as appropriate, I think you can see here this answer is exact. Now here we definitely get 3 SF, but this one you could leave it as 5. As appropriate, they say the word as appropriate. So in this case, it's appropriate to keep it as 5. In the other one, it's appropriate to keep it in 3 significant figures. Okay, moving on to part 2. Prove that sine 3 theta over sine theta minus cos 3 theta over cos theta is identical to 2. So this is an identity. How do we prove an identity? We start from one side and we prove it to get the other side. So here I will start obviously with the left side. Sine 3 theta over sine theta minus cos 3 theta over cos theta. So what we do here is take the common denominator. Who is the common denominator here? Sine theta cos theta. So when we take the common denominator with sine theta cos theta, I get here what? Sine 3 theta multiplies with cos theta, right? Because here we don't have the cos. Minus cos 3 theta will multiply with the sine theta because it doesn't have the coefficient sine. Okay, now looking at this, does this remind you of someone? So remember this rule, sine A minus B. Who is sine A minus B? Sine A cos B minus cos A sine B, right? So does this look something like that? Sine A cos B minus cos A sine B? Yes, right? So what we do here, the A is 3 theta, sine A minus B, 3 theta minus theta over sine theta cos theta. Are you with me? Sine 3 theta minus theta is sine 2 theta over sine theta cos theta. Now, the thing is, we need to get a answer as to there are no theta coefficients. Everything is supposed to cancel out. So how do I fix that over here? We know sine 2 theta, the double angle of sine 2 theta is what? 2 sine theta cos theta. So let's input the value here. Sine 2 theta is 2 sine theta cos theta over sine theta cos theta. So what happens here? You can see the sine to sine cancels, cos to cos cancels, and your final answer simply becomes what? 2. So this is the show that. So we got the identity. Okay, moving on to question number 10. Figure 3 shows a sketch of the curve C with the equation x equals y times e to the power 2y, where y is element of real number. Show that dy by dx is y over x times 1 plus 2y. So how do we get dy by dx here? Now basically x is already subjected, right? So shall we first get dx by dy? Okay, it would be easier to get dx by dy and then convert it to dy by dx. So x equal y times e to the power 2y. So when you get to differentiate here, I'll differentiate with respect to y, getting dx by dy. So here y times e to the power 2y, this is again what? You can't differentiate both of them together. This is again the product rule. So y will stay while e to the power 2y differentiates. What happens when e to the power 2y differentiates with respect to y? E to the power 2y into 2y differentiation is 2. Okay, and we are doing with respect to y, so you don't need to add any other dy by dx because we are doing with respect to y. So e to the power 2y into 2. Then plus e to the power 2y stays. Now while you differentiate y, you're differentiating y with respect to y. Therefore, it becomes 1. Then fix this here. Dx by dy equals 2y e to the power 2y plus e to the power 2y. So when I make it dy by dx, it's going to be the reciprocal, right? 1 over 2y e to the power 2y plus e to the power 2y. Okay, so shall we take the e to the power 2y out? So when I take e to the power 2y out, I get here 2y plus 1. Let's still get the show that. The show that has, there's no e to the power 2y. There's x outside and a y. So how do I get this particular part? So from the first one, they have given x equals y times e to the power 2y, right? Yeah, so e to the power 2y can be subjected here. E to the power 2y subtraction gives you x over y. So replace the e to the power 2y with x over y. One over e to the power 2y is x over y times 2y plus 1. So in the denominator, when you have another denominator like this y goes up. Y over x times 2y plus 1. So this is a show that. So the show that for 4 marks. Make sure you show all the steps to show that. So be careful. Just make sure you show the steps. The next part, given that the straight line with equation x equal k, where k is a constant, cuts C at exactly 2 points. Find the range of possible values of k. Okay. So what do they say here? Given that the straight line with equation x equal k. Now x equal k is supposed to be what kind of a line? It's a horizontal line or a vertical line? X equal 1, x equal 2. What is it? Horizontal or vertical? X equal lines are vertical. X equal 1, x equal 2 likewise. So you can see these vertical lines are driven. Are they cutting at 2 points? No, they are cutting at only 1 point. They are asking you to find here the range of possible values of k where what? Given that the straight line cuts the curve at exactly 2 points. So where do we cut exactly at 2 points? I think you can see at this place over here. You can see we cut at 2 points, right? Can you see? So they want the range of values. They want you to find the range of x values where the graph cuts at 2 places. Are you with me? Okay, so how do we find this value? I think you can see here this graph kind of, you feel it's an asymptote. Do you see? At x equals 0, we can see that it's going towards the graph goes towards negative infinity, the y value. Okay, so how do we get this other value here at this point, this maximum point here? So you do realize that you, I mean, how do we get this other value? Just let me give you a moment to think about this. Okay, so now the challenge is how to get this value here, this maximum point. So do you see this is actually a tangent to the curve here, but now normally when we have turning points, when we have like this dy by dx at the turning point, the gradient is 0, right? But here, do you notice that your gradient is actually, now here the gradient is parallel to x-axis. Then we say when the gradient is parallel to x-axis, it's 0 gradient. But when you have a gradient parallel to y-axis, what gradient do we have? It's the infinity. You have the max. I mean, you have your dy by dx becomes math error, isn't it? Or basically, you could say here, I could give you a short note like this. If you have a graph like this in this manner, for these kinds of graphs, the dy by dx is 0. The gradient of y with respect to x is 0. But if you have something like this, okay, and with when you have dy by dx, now this is, in this case, the tangent is parallel to y-axis, right? In such situations, you could say the opposite of this, dx by dy is 0. because the gradient of the rate of gradient of x with respect to y will be 0 in this situation. It's dx by dy. Okay, so we can think of something like that here, because we want the tangent that is not parallel to x, but the tangent that's parallel to y. Remember, dy by dx equals 0 is a tangent that's parallel to the x-axis. Here I want tangent that's parallel to y-axis. Therefore, it should not be dy by dx, but dx by dy must be 0. Okay, so then I can get this x value here. I need to get the x value. Shall we get dx by dy to 0? So dx by dy will be the reciprocal of what we found, right? So making dx by dy equals 0, what do we find? Taking y to the other side, 0, the x times 2y plus 1. So we get here two values, right? Yeah, we get here x is 0, or because here y multiplies with 0, and that will immediately go away. But here we get two values. Here x is 0 or 2y plus 1 equals 0, which means y equals minus half. These are 2 points. At x equals 0 also the tangent is parallel. I think you can see here that this goes, it goes towards negative infinity. Okay, but another thing is I need the range of x values, right? So I need to actually what? Now I got the y value here. At this point, I know the y value is minus half, but I know I don't need the y, I need the x value here. Are you with me? I need the x value. So what we need to do is we will replace our y value minus half into this equation and calculate the x value. So get the x value. X equals, what do we get here? Y is minus half into e to the power 2 times y is minus half. What do we get here? Minus half e to the power 2 times minus half. What do we get here? E to the power minus 1. Are you with me? So x equals minus half y to the power minus 1 is 1 over e. Basically minus 1 over 2e is your x coordinate. Are you with me? X coordinate is minus 1 over 2e. So if I move the screen now and make this larger, so look at this. This particular x value is x equals, what was it? X equals minus 1 over 2e, right? This is this x value. So now we need the place where the graph, the x equal k line meets the curve at two places. So I told you x equal k is a horizontal line. So inside this range, do you see inside this range is where we meet the curve twice? Do you see each and every one of them meets the curve twice? Okay, so how do we get the range? Where does the range start? The x value range, where does it start? Where does it end? So you can see it starts at minus half. At minus half, if you draw the line, you'll only meet once. So then we don't take equal to, but we take greater than minus half. And where does it end? At 0. So your range of x values will be x is greater than minus 1 over 2e and less than 0. So actually not x value, what value? X is equal to k. Therefore, what value? K. K greater than minus 1 over 2e and k less than 0. So this is the answer you need to give for part B. So part B answer you could write k is greater than minus 1 over 2e and less than 0. Okay. Okay, so this is the end of the January 2022 T3 paper.